So first of all, I'd like to welcome everyone to today's Webinar Wednesday product demo of SOLIDWORKS 2015, specifically dealing with the mold tools environment that's included with every package of SOLIDWORKS. And to get started, what I'm going to do is minimize the PowerPoint here and start with an empty part file that has a couple of planes and sketches over here in the Feature Manager design tree that I've already begun to kind of help us speed along the design of this part. And whenever I'm creating a mold or the cavities for a mold and things like that, I need to be concerned with the model itself and also where it's coming from. So we don't always have the luxury of designing our parts all in SOLIDWORKS. Sometimes we have to take in CAD files from other programs. And so that's where we're going to start this example today, is by taking in an IGES file and showing you how we can build that mold tool even if we get this body imported from another CAD program. So at the top of the command manager here, I've got this mold tools option, and I've also added this button to my command manager to import geometry into already started files. So let's go ahead and open that up and choose an IGES file here. But before I do that, I wanted to show you in this drop down here that there are a number of different file types that can come into SOLIDWORKS directly. And so SOLIDWORKS is a fantastic file translator. We can take in CAD files from Parasolid, IGES, ACES, any of these different file types and bring them into SOLIDWORKS, convert them into a SOLIDWORKS body, and then use all of the traditional SOLIDWORKS tools in order to continue working. So let's go ahead and filter this to IGES here. And I'm going to go to the options here to briefly show you that there are some import options that automatically get applied whenever you bring in an IGES type file into SOLIDWORKS. Now, a couple of those here, like import multiple bodies as parts and perform full entity check and repair errors, are pretty commonplace to have on by default. I've turned them off here so that I can show you what happens when we don't have these automatic SOLIDWORKS tools working in the background to help us when we're designing parts. So I'll say OK there and choose my IGES handle. And once I've opened the body, it comes in here and I can switch it to shaded with edges, I can switch it to hidden lines visible, I can do whatever I want the way a normal SOLIDWORKS body would work. I can go ahead and put this to shaded with edges, and as I rotate around the model, what I want to be looking for is any kind of import errors from when I brought this body in. And it looks like there's a couple of edges highlighted in that corner. Maybe it's difficult to see, but there's a corner edge there that's highlighted in blue. And if I zoom in, what it turns out is that there's a small gap here in between these two faces. And this is exactly the kind of typical error that can occur when you bring in an imported body or surface from another CAD program. So the way that SOLIDWORKS addresses these kinds of issues is by having that import diagnostics run by default whenever you bring in a body. Now recall, I turned that off, so what we're going to do now is go ahead and reposition this in our feature tree here. And what I'm going to do is right-click on this and run those import diagnostics that would have started by default. When I do that, it detects that there is a face that is faulty, and when I look in here, it wasn't even one that I could see or tell was wrong when I first brought in the body. So you can see that the benefit of this tool is finding things that you yourself won't catch with the naked eye when you first bring in a model. So that faulty face there, along with some of these gaps, one of which we had already found, but it's highlighting one over here, so if we rotate the model around and zoom in, we see we've got another one of these little gaps here. Zooming out, it highlights that one that we already found earlier, and then a third one over in this opposite corner here. Rather than manually try to fix any of these things, we're just going to let SOLIDWORKS do that for us, and you see that this attempt to heal all button exists here on the property manager. So when we click that and just let SOLIDWORKS work its magic, wave the magic wand, and all of those little gaps and faulty faces are going to go ahead and repair themselves so that we can continue working with the model in a really fully defined, fully volumized space. So go ahead and say OK here. And the next thing that I want to do is now interrogate this model. I've gotten it from another CAD package, so it's safe to say that I probably didn't have a hand in designing this, at least from the beginning. I may have had some input, but there are going to be issues with this model that I want to go ahead and take it into account before I just start willy-nilly building a mold model around it. In the past, some people have used the sort of quick and dirty way of just extruding a solid up to the surface of a body or up to body to get that formed shape. But what we're going to show you is that the built-in mold tools actually help you take that a step further and formalize that process. So with this imported body, now everything that's here is basically a SOLIDWORKS body. I can click on edges and faces and add fillets, remove fillets, whatever I want to do. And so the thing that I want to check for initially is our undercuts. If we're going to make this part in a plastic injection mold, then we need to make sure that when you pull it out of the mold, there aren't any pieces that are going to get stuck or locked inside of that mold. So let's go ahead and come over to our Evaluate tab, and you'll see here that there's this undercut analysis, and it also has a secondary button or access to it on the Mold Tools toolbar. So we go to our undercut analysis here and choose the front plane as our sort of direction of pull, normal direction. What we see is that it's color coding the different surfaces and regions of the model depending on what kind of undercut it has. Now the direction 1 and direction 2, I'm going to toggle these off because frankly I'm not too worried about those. I'm going to take care of draft as part of the shape of the part for those 2 directions. But when I take a look at the filter, now that it's been turned off, we see that these red faces here are these occluded undercuts. And these are going to be problems when we try to create the part, because if we go to pull it out of the mold, these pieces are going to have some part of the mold lock inside unless there's a relief or a core or a lifter or some other feature of that mold that releases those portions of the model. So now that we know what the problem areas are, this undercut over here on this locking tab and then these 2 little holes here, we can go ahead and take a look at the draft of the overall part and see if the rest of it will come out of the mold. Again, I have this draft analysis tool that's right here on the Mold Tools toolbar. So I'll go ahead and activate that. And I want to set this draft analysis to 3 degrees initially and choose my front plane again as that direction of pull. And no matter which direction I go in, I can see whether or not the faces have enough draft. So if I'm looking at it from this direction, this side of the mold will definitely have enough draft for this face. And if I flip it around the other direction, it looks like most of this will have it, but anything in yellow isn't meeting the threshold draft that we need for this model. But we already have it set to this 3 degrees as the threshold. So if the absolute minimum that we need is 1, we can go ahead and toggle this down, and that refreshes the faces so that now all we're seeing are the ones that need that draft. So I'm going to go ahead actually and reverse the draft the other direction for our analysis. There we go. And what I'm going to do now is fix the faces that need draft. Anything that's in yellow that we're concerned about needs draft. And so over here we see that these 2 faces, as well as the other side of those corresponding faces, are an issue for this tab. If we're going to pull this out of there, we need to add some draft to those faces. Now, because this was an imported body, normally people would think, okay, I have to send this INIS file back. They're going to have to fix these faces here and then send it back to me so I can go ahead and build this. Well, that's not so in SOLIDWORKS. Because we've converted this to a native SOLIDWORKS body and we recognize all the faces and edges and everything, we can actually use some direct modeling to get rid of the fillets right now and fix the model ourselves. We don't need to wait for anybody else. So what I'm going to do is zoom in here. And I'm going to go ahead and remove the curved fillet faces here just by selecting them. From both sides here. Make sure not to get the edges, get the faces. And we'll get these outside ones as well. And what I'm going to do is come down to Faces, Delete, and you'll see that SOLIDWORKS gives us this option to patch, and what it's going to do is go ahead and extend the surrounding faces to a common edge, and so we're going to get our sharp corner back. And so when we say OK here, we see that it removes those fillets by direct editing, and what we get are just the planar faces. So now I can go ahead and use my drafting tools to add the draft and then put the fillets back. So I'm going to go over here to Draft. I'm going to select this top face here as my direction of pull, and then these 2 faces here as the ones to draft. And I want to add that 1 degree. And so I'm going to go ahead and say OK here, and you'll see that the faces update to indicate that that draft has been added to the model. So we'll repeat that trick one more time. Come up to my draft tool, choose this top face, make sure that my arrow is going in the correct direction, and then select these 2 faces here. Now that that model, or that portion of it anyway, has enough draft on both sides, as we interrogate the model from both sides, we see that everything that's important to us is either in red or green. We're not concerned with these yellow regions here or these ones here because the cores and lifters that we're going to create as reliefs for these are going to take care of that themselves. So if we go ahead now and take a look at our model, we're essentially ready to start building that mold. The only thing we do need to add back is the fillets, and so if we come over here to our features, fillet, and then select those same edges that were recreated with that face delete, we can now add all these fillets back to our model so that we don't lose any of the design intent. So let's go ahead now and create our mold tooling. Now, as I mentioned, the old school way is to just kind of create a body and then have it extrude up to the next body and kind of pick up whatever surfaces it finds on that side. Of course, I mentioned that there are better ways of doing that, and one of those is by actually taking into account the shrinkage of the model. So if this was the finished part, then it wouldn't account necessarily for the amount of shrinkage that the part's going to go through after it comes out of the mold. And if we're trying to design the mold, then what we want to do is account for that shrinkage. So some people have done analyses and things like that, but once you know about how much the part is going to scale by, we have a scale tool right here in Mold Tools that allows us to take the entire model and scale it about either the origin or the center right here. And we can do a uniform scale of 1.02 to account for that thermal shrinkage. So now that our part is the correct size, we can go ahead and start creating that mold. Some of the different tools that are included with SOLIDWORKS that help us do that is things that identify the parting line, a tool that allows us to add shut-off surfaces between the two halves of the mold, and then also by creating the cores that are going to serve as reliefs for these different tab features with the occluded undercuts. So let's go ahead and get started first by identifying that parting line. Let's choose our parting line tool here, and we'll choose the front plane as the direction of pull just to set the normal. And once we do that, what we see here is that we can click this draft analysis. And it's going to go ahead and try to find the outermost edges of the model that correspond with the appropriate draft. And when we take a look in here, it's already grouped together these parting lines. We could add additional edges, or we could override some of these things by either undoing or redoing. You take a look here, it says use for core cavity split. And so we're identifying that this split line is essentially going to be where the two molds come together. And what we see at the top is a message saying the parting line is complete, but the mold cannot be separating the core and cavity. You may need to create shut-off surfaces. And so it's talking about the fact that these open regions here make it so that the parting line doesn't have some common plane in order to separate the top half and the bottom half, quote unquote. And so what we're going to do here is actually fill in these surfaces. So we'll go ahead and say OK there, with the knowledge that what we need to do in order to create this tooling mold and get this ungrayed out is to create some shutoff surfaces. Luckily, SOLIDWORKS has that tool for us. Now, for those of you who are experienced surfacers, you might dive directly into our surfacing tools and just start creating a filled boundary surface or something like that in order to create those shutoffs. But for those of you who are not big surfacers, we have an automated tool for that called shutoff surfaces. So I select that. It gathers up all the open internal regions like so, and it tries to apply some kind of tangency contact to the outer edge. Now for this loop over here, this is fine. A flat planar face separating both sides of the mold is exactly what we want. But over here, we have this odd hump, and that's going to add complexity to the mold, and it's going to waste a bunch of extra material. And so when we come in here, what we want to do is change this loop tangency from contact to tangent, simply by clicking on that little property manager. But you'll notice that that doesn't quite get us where we want to be. It gives us a sort of flat plane, and that's not what we want either. So if we actually click on this red arrow here, it's going to switch the direction of that tangency so that it follows the loop of the outermost edge. So once we're done with that, we'll say OK. And what SOLIDWORKS has done is it's created surfaces that essentially touch the top half of the body and the bottom half of the body and meet wherever that parting line is. And so if we take a look here, this surface bodies folder appeared, and we have now shut-off surfaces that represent the sort of inside faces and one that represent the outside faces. So if we go ahead and come into our solid bodies folders here and hide this body, we can now look at the individual halves, so to speak, of our mold surface. So if I hide one side of this, we can see the inside sort of concave part. That's going to be in the upper portion of the mold. And then if we hide this one, you'll notice how it subtly changes for this piece here. If we flip it around to the inside, you'll notice that this cavity for the locking tab isn't in the other one. You'll also notice that when we come to this side, we have this extra lip around the outside that's missing from the other one. So the next thing that we're going to do is add a parting surface. We have the parting line, so it's already defined the outermost boundary. So this should be pretty easy. We can come over here to parting surfaces, and it's gone ahead and found that outermost edge, and it looks like it can add some more material. Now for some people, this is kind of unnecessary, because if you look here, it looks like all it's doing is extending off this face or this plane or this surface that we already have. So what we can do is just reuse that. I'm going to go over to my surfacing tools and use this untrimmed surface. And what I'm going to do is just select this outside face here to create this squarer looking profile, because that one that kind of travels around the edges, I don't really want just a tight offset. What I want is this bulk extra material, and it's mostly because it's curvy and I want my lifter pins to have some meat to grab onto without warping or twisting or bending the part as it comes out of the mold. So we'll go ahead and leave it at this 15% and at the external edges in this property manager and say OK. And the next thing that I want to do is select that parting line that we used and trim this surface back. So I'm going to turn my draft analysis off here so that I can see the fact that it's sort of overlapping in these two regions, and we don't want that. So let's go ahead and choose our parting line here. Come back to surfaces and trim the surface using that parting line, and what we're going to do is keep this selection. So now that we've trimmed that back, we can essentially continue working by adding more parts to this mold sort of concept. So we have the parting surface, and now we have this extra material here that represents the parting surface of the plastic that we're going to cut away, along with those internal shutoff surfaces. So what I want to do is go ahead and trim some of these using some sketches that we already have. So if we're going to go ahead and roll forward here, and what I want to use is one of these profiles that we already have here to trim this surface back to fit inside of the die that will be our mold. So we'll go ahead and use that shutoff profile there, and again turn to our trim surface and choose to keep the inside region like so. Now we have a defined shape for that bulk extra material, and we can go ahead and create now the tooling split that's going to be our mold. So we'll go ahead and come back to our mold tools here, grab our tooling split. The one thing we want to do before we do that, though, is move that surface trim we just created into the parting surfaces folder, so that when SOLIDWORKS takes a look at these things, it knows how to create that tooling split mold based off of these three different surfaces. So we'll come to our tooling split here. We want to choose a sketch, this profile that's going to represent the outermost region for that mold die. And what we get is a preview of that extrude on either side, about the mid-plane of the sketch. And then what we can see is that we can control individually how far that extrusion is going to go above and below that sketch here that represents the split. Now you'll see that because all of these surfaces were organized the correct way, we can go ahead now and just click Interlock Surface for this extra piece here inside and say OK. So this creates essentially the main body of our mold. And so you can see here that if I just take a minute to isolate some of these different regions, we'll hide these surfaces first, so you can see just the mold body itself. So you can see those shut-off surfaces here are represented as part of the mold. And this would be that sort of concave half of it. And if we exit the isolate and choose this bottom one instead to take a look at, you see that we have the regions internally for the tabs and that locking tab. And because we automatically added the 3 degrees of draft to this interlock, we know that it's smoothly going to come out of the upper half of the mold. So the next step is for us to go ahead and add the fill gates and sprues and things like that that we want for this mold. Now, because this thing is going to have these sort of occluded undercuts in here, we want to have it sort of injecting from the side and from underneath. And so rather than create this feature from scratch, people who design molds every day end up using the same kinds of fills and sprues and gates and things like that. So why not save those things as design library features so you can just drag and drop them into the mold whenever you need them. So that's what we're going to do in this case. If I go over to my design library, I've got this mold tools library already set up. And in here, I have this sprue runner gate feature that I can just drag and drop out into the part. And when I do that, it's going to ask me for some positioning in order to place that feature. So if I come over here to my origin, we get a green check mark in the property manager indicating it accepted that setting. And then we'll choose a top plane here to finish positioning it. Saying OK there, now we get the feature inserted, and our fill ports there are now visible. So the next thing that we want to create are the relief cores as well as the lifter for those different occluded features that were in there. So what we're going to do is roll down a little further to our side core profiles. Here, we're going to switch over to our wireframe. And what I want to do is go to normal to this particular face and take a look in here. Now here are those little tabs coming down, and we want the side core profile to essentially come in from the side and provide some kind of relief for these little holes so that they can slide out of the mold in the vertical direction without getting caught with this lower tab here. So what I'm going to do is activate one of our profile sketches here, and we can see that we're actually quite close to where we need to be. So all I'm going to do is edit this sketch and add a collinear relationship between these edges. Now I know that the inside of this shape is fully defined and referencing the edge, the inside edge of this tab. So if something changes with this body, something changes with this model, this edge is always going to default to the inside there. So we'll confirm that sketch, come out into our fully shaded with edges here. I want to go ahead and isolate this lower body momentarily. And what we're going to do is come up to our mold tools, and instead of doing a extrude and then a cut and then a bunch of other stuff, we actually have this core tool already set up to essentially carve out this section of the mold base and leave it as just the core piece. So let's hit that core there, select our sketch. We get a preview inside of the graphics area here. And what I want to do is go blind in 10 millimeters in each direction in order to fully get the width of those tabs. And you can see the hidden lines there showing that we're fully encapsulating the inside and outside of that tab. Now the other thing that we want to be sure to take care of here is which core or body this is going to. Now right now we have it in isolate, so we only see the lower half, but you want to make sure you select just that lower half in here, so that's the only one that gets the cuts and the extrusion. So we'll say OK here, and that creates our core cuts for us. Now, obviously, the issue with this is that if they're going to come sliding out as this is sliding downwards, or if the other piece from the top half is moving upwards, we want to have some kind of draft on those things in order for us to slide them out smoothly. So that's the next step that we're going to do here. Is we're going to go ahead and add draft. I'm going to hide this other sketch here. And the first thing I want to do is move this body up and out of the way. So I'm going to exit out of the isolate here. I'm just going to hide this one. And then over on my Advanced Modeling tab here, I have this Move Copy Bodies option. And what I'm going to do is just kind of drag this up and out of the way here so that I can see these little core profiles here. So we'll go to our Draft Tools. We want to make this go in the correct direction there. And we'll do the same thing, adding draft to these faces to correspond with it. Now maybe that 1 degree of draft isn't quite enough. Maybe we want to have it have 3 degrees to match the rest of this mold body. So that's actually what we're going to do next. Is we'll go in here and edit the feature. We'll just bump up the angle a little bit, no problem. And now you can see this really exaggerated shape here, this sort of trapezoid, and it shows that, yeah, we've got plenty of draft there for those 2 core profiles to slide in and out. So I'm just going to go ahead and repeat that real quick on this side here. Make sure we got 3 degrees. And then do the same thing up here. Now we can just go to the feature tree here and delete that move copy body to get the base of our mold back into the correct position. So now what we want to do is focus on this lifter area since we've taken care of these 2 side tabs. What I'm going to do is roll forward a little bit forward. And actually, I need to use a plane that we've already got in here, our lifter sketch plane. And I'm actually going to flip this around the other direction and go back to our wireframe view. And what I want to do is convert these inside edges here so that when we create our relief lifter, it slides off to the left. So we'll convert entities there. And then using my sketch tools, I'll just go ahead and create the rest of the profile here. We want to make sure that we're parallel with that first option there. And then we'll drag our endpoint up to meet with it. Now we don't care that this extra portion is sticking out the top because we are going to use the core tool in order to make sure that it's cut flush surface or cut flush with the inside surface here. So the only thing we need to add now is some dimensions to fully define this thing. So let's grab our Smart Dimension tool. We'll put an 80-degree dimension here. And then separate these 2 parallel lines here by 6 and make this one here 6 tall as well. So as I mentioned, that essentially fully defines it except for the stopping point at the top, but we really don't care about that because as we exit the sketch and come back to our mold tools and choose core, we see in this preview that what's going to happen is we go ahead and make this 5 wide in both directions. And yet, because all we're doing is using the surface of this body as the cutting tool, it's going to trim it back flush with the top of the surface here. So now our lifter is exactly the right shape. So the next thing that we got to do is add some ejector pinholes and some core pins to this model. So let's go over to our ejector pins folder here, and I've got 2 sketches, one that represents the hole itself, and then another that represents the locations on this model that we'd like to have them at. So the first thing that I'm going to do is create that hole. So I'll go to my ejector pin hole, go to my features, do an extruded cut, do a through all in the correct direction. But what I want to do is come down to this feature scope, and instead of selecting all bodies and auto select, I want to just choose this lower body as the one that will be affected by that cut. So we'll say OK there. And to wrap this up, we'll go ahead and choose that location sketch and do a sketch-driven pattern using that cut extrude we just created as our feature to pattern. From the side, it looks a little bit like a disco ball, but if you go ahead and go normal too, what you see is that they're all in specific locations to help push the final injection plastic part out of the mold. So go ahead and say OK there. And now we've got the holes all in our model ready to go. So now we'll create the core pins that actually lock this thing into the die. So we have another sketch for that already created here in the side of the Feature Manager design tree. And if we open this up, we've got a pin profile and a heel profile. So if I go ahead and choose our core pin profile, and if we go to our core tool on the Mold Tools Command Manager tab here, it's going to see those sketches and try to create extrusions from them, essentially, holes and extrusions to go with it, just like the previous cores we had. And so we're going to go ahead and select this lower body here. We're going to go through all in one direction and 0 in the other. And once that's done, and if you want to be sure, you can make this a 10 just in case. We'll hit OK here. And now we have the ejector pins located here. We also need to create a core for the heel profile, so the wider portion of those. So again, we'll select the sketch, come up to core. This time we're only going to do a 3mm extrusion in one direction. And again, we'll select this lower body as the one that we'll take that core from. Now what I want to do is hide this body momentarily, because what we have are pins and bases that are separate. The heads and the pins are not one singular body. And so what we'll do here is a quick combine using our advanced modeling tool. So you have this combine here. I can grab my solid bodies and then just combine all of these using that add tool. And now that all of those are combined into one body, let's go ahead and take a look at everything that we have. We have the lifter over here. We have our locating core pins. Our ejector pin holes are in the lower portion of the model, and then we have these side cores. And if we take a look at all those bodies here, what we have is a completed mold that's ready to be inserted into the mold base and used to create our plastic injection molded part. We could also use this as the basis of a simulation in order to find out where thin regions in the plastics might be, or where surfaces might not have a uniform sort of curve or tangency. And a lot of those plastics questions can be answered by using plastic simulation. And so actually later on at 11 o'clock, Glenn White is going to be doing a presentation on SOLIDWORKS plastic simulation. And so be sure to check back and take a look at that if you want to see sort of the analysis side of this model and of this mold. But once we've essentially completed this, what we need to do is get it into the larger assembly of our mold base. And now there's a couple different ways of doing that. We could do a save of all the bodies. We can try to do save all the bodies individually and then assemble them together in an assembly using mates. But SOLIDWORKS makes this really easy because we can just save this entire thing out using just the save bodies option. So the one thing that I am going to do is go ahead and make sure that all of our bodies are shown except for the original one that we imported, because now we're actually not going to use that anymore. And for now, we actually don't need any of these surfaces either. So what we're going to do is right-click on the Solid Bodies folder here, and you see that the Save Bodies option is there. Now, you might be tempted to go to this Insert into New Part, and the thing is that we don't want to create a part. We want to create an assembly. So if we go to Save Bodies, that property manager gives us the ability to save all the parts individually, but also keep their relative positions in an assembly as well. So I'm going to make sure that I clear this consume cut bodies. We don't want to lose any of these things in transit. I'm going to go ahead and come to Browse here and just give this thing a name on my desktop. We're going to call this the mold insert. And go ahead and save that there. Auto-assign names to all these different bodies. We could override and change these if we wanted to. And once we're happy with these settings, just go ahead and say OK here. Saves all of the bodies to the same directory folder. And now if we come to our assembly, what we see are all the bodies are represented as individual parts fixed in space. And now we can now add this insert into our larger mold base as an assembly. So I'm going to do that next. I'm going to come over here to Open, grab that mold base assembly. And the first thing that I want to do is insert that assembly now into this larger one. So if we just go over to our Insert Components tab, because it's open in memory, I can go ahead and just choose it. However, the nice thing is that we have these display states here so you can actually see that happen. So we'll go to all of our plates transparent, hit the Rebuild button here so we can see what's going on. And inside of here is where that's going to go. So if we go ahead now and just go back to our Insert Components, choose our mold insert, we could try to position it, but if I just hover over the green check mark, it's actually going to tie it in the correct spot. So we'll say OK there. And now I've got one of my mold bases inside. And I'm going to go ahead and make this transparent as well. And what I want to do is mirror that entire assembly over to the other half here. So if I go down to my linear component dropdown in the Assembly tab and go to Mirror Components, I can choose my right plane as the plane to go ahead and mirror about, and I'll choose this mold insert assembly as the components that I want to copy. I'll hit next here, and you'll notice that it starts to position this initially on the other side, and I actually didn't like any of these different options that it gave me by default. So I'm going to choose this third one here because it's the closest, but as it turns out, what we're creating is a left hand and a right hand side part inside of one mold. So what we're going to do is create a opposite hand version for this copy that we're creating, and when we say OK, it creates opposite hand copies for everything that we need. So we'll make the lid of that transparent as well. So as we come over here, the next thing that we want to do is actually rearrange these components so that they go with these sub-assemblies in this larger assembly appropriately. So you'll notice here that there's a fixed half at the top, there's a moving half at the bottom, there is an ejector set that slides in and out with an independent plate, and then we have these side core slides 1 and 2 on either side. So this is set up and mated the way a real mold-based die would be. And so what we want to do is organize the parts so that they go with the sub-assemblies that they would go with in real life. The nice thing is that even though we've created the mold insert as sub-assemblies, we can dissolve them inside of this assembly and rearrange the components however we like. So I'm going to dissolve this mirror first, and then I'm going to come up here and dissolve the sub-assemblies themselves. And we don't need to save anything. So now we've got all of these bodies here as individual parts, and currently they're just sort of mated in place with this fixed reference. So the next thing that I'm going to do is activate my display state that removes all of the plates and leaves just the stuff that we want to work with here. So I'll make this not transparent anymore. And now we can really quickly sort of break up these old assemblies into the correct portions that we want to have. So I'll select these two upper pieces here. I'm going to move those into the fixed half of our mold base. And then I'm going to grab these two lower pieces here and move them into the moving half of our base. And then I'm going to take these locating pins here and also put those into the sliding base. So we'll go ahead and put those in the moving half there. What we're left with are these side ones and the lifter. So let's go ahead and choose our two side ones here. And we'll move those into side core slide 1. And we'll choose our lifter, and we'll move that into lifter 1. Now these extra 3 that we have over here, they're not needed because they're actually going to be mirrored over. So let's go ahead and select these 3 here, right-click and delete. And if we now go ahead and come to our plates transparent and switch over to our moving half, actually we have one last mate to add. You'll recall that we put this all in here, but this piece here can actually still slide in and out. And so what we want to do is mimic the correct motion. So we're going to go ahead and slide this out of the way, grab its back face, and get a coincident mate with that one there. And that will also be applied to the mirror. So now that all of the mates are in place, we can go ahead and try to view the motion of this new assembly. Let's go ahead and switch our configuration from the fully closed to the mold opening option. And if I go ahead and drag this down, you see how the side slides, they go ahead and slide outwards. And if we sort of angle ourselves so you can see the side cores here and repeat that motion, you can see how they follow along with the motion of those side releases. So if we slide this thing all the way down and open, what you can see then is just the ejector pin. So right now we have just the one, and what we're going to do next is go ahead and fix that so that all of the ejector pins are in the correct locations in those holes that we just created. We have just a couple of other edits we want to make in here, so let's go ahead and go back to our fully closed configuration, and switch over to the all plates removed option, because you'll recall that these lifters here, they don't necessarily meet up with where the little lifter piece is going to be. And so what we're going to use is some of more of our direct editing parts. We're going to go ahead and edit this part in context, and then I'm going to grab from my mold tools this move face option so that I can offset it from the bottom and have it meet up roughly with where it's going to go eventually, just to get that visual for us. So we'll go ahead and come back to our transparent plates here. And let's go ahead and open those ejector pins now. So we'll go ahead and zoom in here, grab that ejector pin, and open the part. Now what we see is that the sketches that we need are already in here because this part was originally created in context. The only thing that we're going to do is roll this back a little bit and bring in some surfaces that we can use to help trim the tops of these pins back so that we have them flush with the actual mold shape. So if we come over to this bezel, you'll see that there's some sketches in here. If I right-click and edit this feature, it brought in the unabsorbed sketches, but it didn't bring in any surface bodies. So I'll go ahead and toggle that on so it brings in the surface bodies that we had created earlier when we first made the mold. With that in place, we can go ahead and come up here, and I actually just want to take a look at one of those surfaces, this one right here that has the extra lip on the outside. So we'll go ahead and create our pins using a sketch-driven pattern and copying the body of this pin here. So if I come into my sketches and find the locations, there's our sketch locations there. We can go ahead and come over to features, sketch-driven pattern, and instead of using the features, we're going to use the bodies and copy this body here. With all those pins in place, we can now use a cut with surface to trim these to the top because we brought this surface in with us. So if we go back to our mold tools here, surfaces, and we can use cut with surface. We'll go ahead and select the surface as the cutting tool. We'll select all bodies for the feature scope and make sure that that arrow is pointed upwards so that it removes just the tops, like so. And because this is going to be mirrored on both sides, we're going to have the left hand and the right hand side. I'm going to go ahead and choose our right plane and come over to Features and Mirror and select all of the bodies that we have here to mirror. Make sure you don't miss any. Preview looks good. Go ahead and say OK, and now we have the right-hand side ejector pins. And if we just Control-Tab back to our main assembly here, it's going to go ahead and update. So that now if we switch over to our configuration mold opening, we can take that ejector pin slide and see how that moves up and down. And we'll just go ahead and hide this surface here that we don't need. And we'll also hide these sketches here. So now we can see how the ejector pins slide up and down along with the lifter. And you see that when they're all the way bottomed out, they're completely flush with the surfaces of the mold. So that's everything that I have to show you all today for SOLIDWORKS 2015 mold tools. If you have any questions, I'll be sticking around for the next 12 to 10 minutes to answer those for you. And if you have any further questions or if you'd like to see a live demonstration of this at your business, go ahead and contact our local office, and Hawk Ridge representative will be sure to get you signed up for one of those demos. Once again, thanks everybody.